science and look for science in anything around you, anything you do, like flipping a water bottle.
No way.
Yes way.
No, are you kidding?
I-
Let's do that.
All right, I think
I've
that's
never
an
done
awesome
that.
idea.
Okay.
So for today's experiment, I think we're going to flip a water bottle that has different amounts of water. How about that?
That's a good one.
And then what we're looking to see is which water bottle is going to land upright. Do you have do you have any sort of idea or prediction?
Trying to think which one and trying to make a prediction here.
Well, I think we have to think about what we already know about the water bottle flipping.
Absolutely.
So since we've been teachers in the classroom, we've seen our students flip these things
A lot.
I think we should use that as our research,
Okay.
and then we can make an educated guess of which one we think is going to land the most.
All right. So based on my prior experience and what I've seen students, I think, from what I remember, I think they use a bottle that looks about half full. In my experience, that's what I think might work.
What do you
So
think,
I
Miss Sandy?
was thinking the same thing, trying to remember what my students have been able to successfully flip, and it seems like it was half.
Yeah, well, we know it's not full.
No.
So that gives us a 50-50 chance of getting this right. But I'm going to go ahead and go with y'all too. I'm going with the half full. It's going to be, so that would be our what?
Prediction.
Prediction.
And we're going to use our prediction to create our
Hypothesis.
All right. When we do a hypothesis, we want to make sure we state it in a way that you can test it. So we're going to use an if-then statement. So if we flip a water bottle that is full, half full, 1/3 full, then we will see it lands on the bottom most often with the bottle that's half full of water.
Okay,
Okay?
I think that
So-
sounds good.
In our hypothesis, we actually are stating our independent variables. And from what we've learned this week, one of our vocabulary words, independent variable, is what are we changing in the experiment? What's different?
What am
And what am
independent
what am
changing?
I changing? So we
Okay.
see we have the same drinking water bottle, but what's different is what?
What's different?
What's the difference?
The amount of water.
So the amount of water in the bottle, that's the independent variable for this experiment. Now what we are measuring at the end of the experiment is our dependent variable, our results. And our results are going to be the number of successful flips that we have. So that means it has to land on its bottom.
Okay.
Now, when we do a controlled experiment, the only thing that we want really to be different is the independent variable. Everything else needs to stay the same.
Oh, I know that word.
What?
Constant.
Constant. It has to stay constant.
That's
So-
a math word too, you know.
Oh, it's a math word too, everybody.
Math words.
Making
Stays the
connections.
same.
Making
Yeah, it
connections.
is. Okay.
So some of our constants, what are we keeping the same?
The liquid is the same. They're all full of water, the same liquid.
Right. It's not like we have soda in one and vinegar in another and oil in another. They're all the same liquid water. What else are we keeping the same?
The
Miss-
bottles are all the same. It's
They
the
are
same
all.
brand and same size.
Exactly. So that is
So that's the same.
important. What else?
Well, when we do the experiment, whoever is going to do it, I think it's going to be me. I'm going to flip it on the same surface. So it won't be like on this table and that table and the floor. It's all going to be landing on the same surface.
Okay, so we have the same person doing the flipping each time and the same countertop, so the same height. And we've got all those listed here. So our independent variable, dependent variable, and constants. It's always important to know those parts of our experiment. Just to give you some measurements, if we were to look on the bottle, and we're talking about full, half full, and 1/3 full, what is a full bottle of water? If we look at it, what do we see?
You could
It's
see,
half a liter.
yeah, 500 milliliters, half a liter,
And
right?
so you can see that on the water bottle down here. And so we wrote 500 milliliters. When we poured half of it out, half of 500,
250.
250. So this bottle has 250 milliliters, and this one, it's about 1/3, and that's going to be about 1/3 of 500 is 167 milliliters. All right.
Alrighty.
We've got our data table, and you are going to have this in your Google Classroom assignment as well. So you will be able to, you can use our experiment, or you can try this on your own and collect your own data. So we're going to try this now, Miss Sweeney.
Okay, so I have a question though.
Yes.
Why do I have to try it so many times?
Well, Miss Hamby, why is it important to try it so many times?
Because to know if you're successful, you have to repeat the trial. In science, we repeat our experiments over and over to have things, so you can compare your
Yeah.
results.
And
Can
we
make
wanna
it
make-
more accurate.
We want to make
Accuracy.
sure our results are reliable. If
Woo.
we just do it once, we
Yeah.
don't know if it's a fluke that she landed on the table or not. So
Pretty
maybe-
sure that's gonna be a fluke.
All right, so
Okay, so I'm gonna do the first full
full
bottle
bottle,
first.
10 trials. We're gonna do a check if she lands it correctly and an X if she doesn't.
Oh, the pressure's on.
All right,
Okay,
10
you ready?
times,
Here we
yeah.
go.
Nope.
Nope. 1, 2. Alright, I'm gonna try it. Oh, 3.
It's kind of close.
I stink. 4.
The skill level is
on its lid. Come on. 6. All right, I'm gonna do it slower. 7. 8. I don't know about this one. 9.
All right.
And
Oh, man.
loser.
So we got 0.
Yeah.
0 successful lands on the full bottle. So now we're half full. 10 times, Miss Sweeney. Go
Okay,
for
here we
it.
go.
Good luck.
1. Oops.
great.
It doesn't even flip over.
3.
Okay,
Come on,
flip.
sweetie, make it flip all the way.
Why does it keep? I think it's really funny because I'm flipping it the same and it won't even.
Hey, try it higher, maybe it'll.
I'm gonna.
See, guys, you can do this at home and have as much fun as we are.
Yes.
All
And
right.
I bet
It keeps landing on the
I bet
side.
you
I think that should have been our
the
experiment.
students at home are going to be probably a
You
little
all need to do
successful.
this. This is
There you
something
go.
that you can
Okay,
try.
that was 10. Oh, no.
Okay, I'm gonna put this one like this. 'cause
And that
that's
was
how it landed the
our-
Oh,
most.
that's the one we predicted.
That was our prediction.
That one tried to land on its head most of the time.
Oh,
This one landed on its side.
Here we go.
Come on, let's go. All right, here we go.
A third full.
Oh!
The first one. Go, sweetie.
Oops. All right.
Oh,
Oh no, hang on. I got 1. Oh, almost. How many more tries do I have?
Several.
That didn't work. Oh! Come on now.
Close.
All right.
Oh.
Oh, so close, so close. Yay!
2!
Oh, so close. One more time, Miss Sweeney.
Okay,
Make
this is
a good
it.
one.
Come on. I need
You
at
gotta
least
make it.
3. This will be.
Oh, but you know what?
Two.
We
This
have
one was-
repeated trials, and our results, we got 0 successful lands on our full bottle, 0 successful lands on our half full bottle, and that's what our prediction
That
was.
was our
Yeah.
That was our hypothesis.
Yeah.
But we got 3 successful
Yay!
flips.
3!
Or did we get 2? My bad. We got
Two.
2. We were really hoping for 3, but
Yes. Yes.
Almost.
that's all right.